Alright, hello Math 6 students. Today we're going to be learning 8-3 area of rectangles and parallelograms. We're going to do some practice with this today and tomorrow, and then next week hopefully you'll be back here and we can start fresh with 8-4. Area is the amount of surface that a figure covers. So if you remember from the review worksheets you did last week, there was a couple problems in there with area and perimeter. Perimeter goes around a figure. So perimeter, we would be looking for all of this, the length around the figure. Area is totally how many squares can we fit inside. So I'm thinking how many squares fit inside each figure. So if we want to estimate the area of an irregular figure, we're going to divide this up into squares. If you look over to the text to the right, I took this from my textbook, count full squares. So we can see the red squares, all of these red ones are totally full squares. So we count up all of those and we get 16 red. Then we count up the almost full squares, which are the blue ones that they colored. The blue ones we go ahead and count as 1, I believe. Let's see if that's what they did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are almost full, so they just kind of estimate it and say they count as 1. Then we look at the ones that are about half. About half are the ones represented in green. So I have 1, 2, 3, 4, I think just 4. So that means 2 full squares. 2 halves make 1. Then we add them all up together and we get 29. So if the area of this area equals 29, we have to label with everything. Everything we do, we're going to label. In this case, 1 square, if we look down here at the very bottom, 1 square equals 1 mile squared. So our label is going to be in miles, M-I squared. Area always has the square on the end. So if you give me 29 miles, you're going to give me the wrong answer. I'm going to have to dock you a point for not labeling correctly. Okay, so most of you know the area of a rectangle, the formula for that, which is area equals length times width. We get that by looking at a rectangle like this and dividing it into squares. And if we count up all those individual squares, like we tried to do with the irregular figure, then we get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I noticed that I could do 1, 2, 3, 4 times 1, 2, 3. Or length times width. So area equals length times width. Area equals 4 times 3, which is 12. Then we have to label the area of the rectangle is 12 square units. Hopefully most of you learned that in 5th grade, so that this is a good review. If we look at example 2, and if our directions say find the area of a rectangle. So for your work, I want you to do A equals L times W every single time. You would come over to the side, A equals length times width, and then you're going to plug in for your next step, A equals length times width, then you solve, A equals 104, then you label with it, and my label happens to be meters, so it's meters, but I'm dealing with area, so it's meters squared, and circle your answer. So for me, since we're doing this kind of virtually, you're going to do this on a piece of paper, either in your notes, for numbers 1 through 10, your assignment that comes after the video, you're going to either do that in your notes or on a separate sheet of paper. And I want to see these steps, 1, 2, and 3. But for today, after you do that, just send me a quick answer key. So you're going to have an email that just has number 1, area equals 104 meters squared, or squared meters. Okay, number 2, A equals 102 inches squared, whatever it may be. Okay, so sometimes I like to say a different formula for rectangle, just because it kind of helps me remember in general for parallelograms, which we're going to do next. So you can also say that the formula for area of a rectangle is A equals base times height. So this would be my base and this would be my height. Either way works for me. So if we look at this next example, it says you can use the formula for the area of a rectangle to write a formula for the area of a parallelogram. So here's a parallelogram. Parallelograms have two sides that are parallel. So if you notice, this side is parallel with this one, meaning it will never intersect. And then we have this side is parallel with this one. So those two lines are never going to intersect. That's what makes a parallelogram. But if I kind of draw the height here, and if I cut off this section and I insert it over here, now all of a sudden I have a rectangle. So that's why it's the same formula for a parallelogram as it is for a rectangle. The area of the parallelogram is going to be A equals base times height. For this one, you cannot do area equals length times width. Okay, you can say area equals base times height for a rectangle, but not area equals length times width for a parallelogram. Okay, if we look at example 3, the directions say find the area of a parallelogram. So, parallelogram, the first thing you're going to do is write A equals base times height. The second thing you're going to do is plug in what your base and your height equals. Your base equals 2 1/3. Your height equals 3 1/2. In order to solve for this, multiply these two mixed numbers together, I first have to make them in proper fractions, which is where they get here. They do 2, let's see if I can change my color so you can see a bit better. They do 2 and 3 together, so 3 times 2 is 6, plus 1 is 7. 2 times 3 is 6, plus 1 is 7. And then you multiply straight across and you get 49 over 6. You simplify, you have to simplify, and then you label. Okay, and you get 8 1/6 inches squared. So in your email that you send to me with your answer key, you're going to have A equals A, it's probably going to look like this, do a space, slash 1/6, it'll be kind of weird. And then you can say inches squared, SQ. Okay, this is what can go in your email to me. On your piece of paper or in your notebook, you need to have all of these steps. Okay, you're going to have one type of problem like this example 4 for today and also for tomorrow. The word problem says a rectangular park is made up of a rectangular spring-fed pool and a limestone picnic ground that surrounds it. The rectangular park is 30 yards by 25 yards, and the pool is 10 yards by 4 yards. What is the area of the limestone picnic ground? So the area that we're looking for is everything in brown over here. I want to know what the area of that is. So using our number sense and our just logic thinking, I'm going to need to find the area of the big thing, this big outline, minus the area of the pool. I'm going to have to do both of those, and then what's left is going to be the area of this limestone picnic ground. So if you see the formula they have park area minus pool area equals picnic ground area equals that brown patch. The park area is going to be base times height, 30 times 25, minus the pool area is 10 times 4, or 40, equals, that's where your variable comes in. Your variable is what you're looking for. And in this case, they chose n. So then we simplify, 750 minus 40 equals 710. Then you label. The most important part, making sure you label your answer. 710 yards squared, because it's area. Okay, so that is it for today. As far as watching the video, make sure you complete numbers 1 through 10 submit an answer key to me, but make sure you keep your work so that way we can go over them and we can stay organized. Tomorrow you will do numbers 11 through 20 in the exact same way. All right, have a great week, and I'll see you all on Monday.